Rick, you think we're ready to push the button?
We're all good to go, Paul.
All right, let's begin.
Okay.
Ladies and gentlemen, welcome to the first of this year's webinars in the MWM program. Our speaker today is Megan Mako, who is on the faculty at the University of Florida. So go Gators. She is the author of 2 supplements to the outstanding introductory statistics text by Alan Agristi and Chris Franklin titled The Art and Science of Learning from Data. It is one of my favorite books. Megan is a judge in the annual ASA Student Project Competition, and she's going to tell us today about how your students can enter a project in this year's competition. As we go along, if you have any questions, please feel free to ask them, and we will also leave some time at the end for Megan to answer any additional questions that you may have. So Megan, please tell us about this year's Student Project Competition.
Hello, everybody. Today I'm going to talk about the ASA project competition, as Paul said. So I'm going to talk about several different things. I'm going to talk about what is a project, how this can satisfy the national mathematics standards, break down the individual parts of the projects and give some tips on how to make really good projects, how you can enter the contest, talk a little bit about the winning projects this year, and then talk about how the projects are judged, and then talk about some frequently asked questions that we usually get about the project competition. So what exactly is a project? For a project, a student or a group of students was going to come up with a question about anything that they're interested in, something that they can collect data on to be able to answer that question. So they should design a method to get that data, and then they'll summarize that data using summary statistics and graphical techniques. Then they'll analyze that data. Now that's going to vary based on the age group. We have some students from the 4th through 6th grade who participate, all the way for those in the 10th through 12th grade who participate. So the analysis of the data may include just looking at graphs and summary statistics, or it may be using some of the AP statistical inference techniques. And then they'll make a conclusion that answers their initial question. And then probably the most important part, then they reflected on the process. What went well, what could they have done differently or better? Then they write up their findings in a written report, averaging about 10 pages. This is the big difference between the project competition and the poster competition. This is actually a written report that allows you to communicate with others. Before we go and talk about each of the different components of the project competition, I want to address the fact that, yes, this does satisfy some of the national standards. I just went and looked briefly at some of the standards for the different age groups and found situations where this project definitely met some of the expectations. For instance, for grades 3 through 5, one of the expectations is to design investigations to address a question and consider how data collection methods affect the nature of the data set. So this project competition is doing just that. As well as for grades 6 through 8, the expectation is to formulate questions, design studies, and collect data about a characteristic shared by 2 populations or different characteristics within one population. Once again, that ties in really well. And there are other expectations, obviously, for these grades and the statistics probability component that also relate really well to the project competition. And then we have grades 9 through 12, and one of the expectations was to compute basic statistics and understand the distinction between a statistic and a parameter. Also, you can see how that would tie into the project competition. And these standards are listed here at this website. I went and briefly looked at 2 states. Unfortunately, not for the 2 states for our 2 participants right now, but I'm sure that most state standards will also be met by doing the project competition. I encourage you to look at your own state standards. So let's look down at the basic components of the project and how to encourage your students to make a really good project. The first part is coming up with a question, and this is probably one of the hardest parts, to come up with a question that for the students to come up with a question. So I would encourage them to have brainstorming sessions where they just write down whatever they can think of and not throwing out anything because they think it's silly or strange. Just write it down and to let the thought process keep flowing until they can come up with several ideas that maybe that they could start to work on and finesse. Have them think about their hobbies, music, favorite games. Have they ever had any questions about some of those things that would make a good project? Or maybe they saw something in the media that interests them. Once they have an idea, it's really important for them to come up with a proposal that other people talk about and think about. So maybe the student presents the proposal to a class, to a group, or maybe just to a partner, and then they kind of talk about it and critique that idea. Some things that they need to think about. Is it possible to answer the question that they have? For instance, I've seen some science fair projects that start with a very broad topic. Is there really global warming? Although that's a very interesting question, it's very difficult to answer in a project of this level. So perhaps a much more focused question would be better. Are there any ethical concerns? I mean, if you're dealing with people, you need to think about that. If you're dealing with plants, maybe not as much of a concern. And then with their question, they really need to make sure they have a question that can be answered with data. So that at this point, they really should be thinking about that. One of the things that we find is that sometimes the idea is too broad. It really needs to be simplified and kept simple. A simple, well-thought-out project is much better than a very complicated project that it's hard to figure out what's going on when you're reading the write-up. It's also a really good idea to be making a comparison between two groups. So, in instance, instead of just talking about, what are students' typical favorite types of ice cream, maybe you should be comparing, the students could compare between males and females or between 4th and 6th graders.
Megan, this is an excellent list. Thank you for sharing that with us. I'm going to hand this out to all of my graduate students for their graduate thesis and dissertation work. So once we get going with our question, then the students need to figure out how they're going to collect their data. Now, technically for the competition, we don't require that the students collect their own data, but by the judging rubric, those who collect their own data are scored much higher than those who don't, because we feel that students learn a lot through the data collection process. So if they decide to do a survey, then they need to include that in the paper, and they also need to make sure that they include the raw data as well. What else do they need to consider in the design stage? I like to tell my students it's almost the 3 R's of experimentation. They need to make sure they randomize, replicate, and control extraneous variation, so not an R. If possible, they need to randomize. For instance, maybe they're interested in determining how fertilizer affects growth of plants. Well, in that situation, you would want to randomize which plants gets what fertilizer. Replicate. Sometimes we see projects where only one plant would get fertilizer A, one plant would get fertilizer B, and then you really can't tell if it's because the first plant that got the first fertilizer did really well because of the fertilizer, it was just a lucky plant. Now we realize that there are budget concerns here, but an effort to replicate definitely should be shown. Also, some thought needs to be given to control. So we look for that when we're looking at judging the competitions. Did they have, in the example of fertilizer, a group maybe that didn't receive any fertilizer? Did they make an effort to make sure that the conditions were all the same for the participants? So we're looking for those types of things. Then we move into the summarizing the data stage. It's really important that the graphs are easy to read and are appropriate for the type of data that's being collected. If it's quantitative data, so things like heights and weights, then histograms, simile plots, or box plots are really good graphs. Where we usually see the problems is with categorical data. Bar charts are really good. Pie charts are okay,
But don't use the fancy graphics that you might see in the Excel pull-down list for graphs, because a lot of those 3D graphs are really, really hard to read and make good comparisons. So keep it simple, easy to read. That should be the focus, not trying out a new Excel graphic. Then we move on to the analyze data stage. Now, obviously, we change our expectations for different age groups. For the younger age groups, this may just be looking at the graphics and summary statistics and drawing any associations that you might see, making sure that it gets tied back to the initial question. For the 10 through 12th graders, there might be some cases where statistical inference might need to be used, particularly for an AP Stat student, then that would be definitely appropriate. However, our expectations are not above the AP Stat level. We would like to see things that are covered in the AP Stat course, but we don't need to see two-factor ANOVA with interaction or multiple regression. We're not looking for that. We're looking for things that tie in with the AP Stat curriculum or below that. So keeping that in mind, it's really important when we read the report that we understand the knowing alternative hypotheses. There was one project this year that had 5 different hypothesis statements, and it was really hard to figure out what was going on because they weren't clearly, the notation wasn't clearly defined. We also find that students tend to not check the assumptions for the test. This is a really bad habit that we don't want them to get into. We really want them to check the assumptions and show that they did that in the report. Make sure that they clearly give us confidence intervals or p-values or whatever is appropriate, and then interpret those correctly. We're really looking to, when we are doing the reading, to see, do they really understand what they're doing? So the student really should have a firm grasp of whatever they're doing. If they don't understand a more complicated analysis, maybe they need to be doing a more simple analysis that they understand. When they get done with the analysis, it's really important that they explain their conclusion, something that, in a way that everyone understands what's going on, not just people who happen to be taking a stat class with them. Then we move on to probably one of the most important parts of the projects. We realize as judges that no projects are ever perfect. So what we're looking for here is that the student realizes that there were problems or errors or things beyond their control that happened, and they know that it should have been done differently. For instance, this year we had a project who ended up only having a sample size of 6. She started out with 125 volunteers, but by the time she got done, only 6 people completed the survey. She realized that wasn't enough, but a lot of those factors were out of her control. So this part here is really, really important to the judges. Not only, so not having this component in a project is a real weakness. Showing that there are problems in the project is actually a strength. And here are some common problems that we see in the project. For the younger grades, sometimes we get questions that are kind of unclear and unfocused. Then they're a little bit more difficult to answer. As judges, we don't mind the students getting help. In fact, we think it's good that they receive help when they don't understand something. However, they need to let us know how much help was given so we're not guessing during the judging process. It's also much more interesting to make comparisons between populations or between 2 treatments. Just finding out what type of favorite ice cream isn't very interesting unless maybe you're making a comparison. Then finally, and then we get to the 10th through 12th grade. So here's some of the more common problems that we have. The confusing or unclear hypotheses, using statistical procedures beyond the AP level. We really don't want to see them unless they're, the student just happens to know how to do that. Maybe they're taking for some reason, taking a college course and they know how to do it. But that's not what we're looking for, and that's not what we're awarding. We really want to see clear, good analyses. And if that's a 2 independent proportion test, that's wonderful. Also, not checking assumptions, common problem. We'd really like to see projects that are checking assumptions on a regular basis. We'll also see some accepting the null hypothesis. This would be like saying that someone in the court system was proven innocent, and we know we don't do that. So make sure that the terminology is correct. Make sure that confidence intervals are interpreted correctly. They're estimating population parameters, whatever the parameter might be in that case. Make sure that R squared is interpreted correctly. We also see this often. It's a percent of variation of Y explained by X, not the percent of Y explained by X. Then we move on to the write-up. The projects average about 10 pages, but we're not just counting the pages to see if they meet that criteria. We're actually much happier if it's a shorter, well-written paper that clearly explains the ideas of the project and the analyses. So we're looking for papers that exhibit clear, concise writing with correct grammar and spelling. And it should be at least 12-point font. Okay, before I move on to some of the other steps, anybody have any questions?
Here's one question, Megan.
Mm-hmm.
I certainly agree wholeheartedly with your statement several slides ago about the importance of reflection.
Mm-hmm.
And how much of the student's reflection typically would you expect to see in the write-up?
What do you mean?
Well, the conclusions that they come to, it would seem to me, ought to be more important than the question that they're asking.
Yes.
And so, would you agree that the emphasis in evaluating their write-up ought to be on the outcomes of the reflection?
Yes, I would definitely say that. It's more important to us that, not that one type of plan did better than another type of plan in terms of growth, but rather that they, in the reflection, really showed that they learned something and they had a really good concept of the scientific method and the analysis that they did. So the reflection is very important.
So, yes, and in a sense that goes beyond really the experiment. It really gets down to what they as a person learned from the experience overall.
Mm-hmm. Yes.
Okay, thank you.
Anyone else?
No, not right now.
Okay. So then I'll briefly talk about the top winning projects for this year. For the 4th through 6th graders, we had Who is the Biggest Drinker? And when my husband saw that initially, he was like, what are they drinking? And they were, the student was interested in who drank more soft drinks, adults or children. And her hypothesis was that adults would drink more soft drinks because they didn't have anyone to tell them that they couldn't drink anymore. So, and hers was a very simple project. She actually hand-drawn her graphs, but it was a very good idea and well thought out. And then here we had the 7th through 9th grader winning project. And what she did was she compared 2 different ways of learning how to spell. One way where you just listen to words and then being spelled to you, and then several days later you took a spelling test. And then the second way is she had them listen to the spelling of the words and then vocalize the spelling of the word. She thought that maybe because that would use different parts of the brain that might help some people spell better. Hopefully that might help some of us who can't spell their way out of a paper bag. But so that was very nice. And then we had the top winner for the 10th to 12th grade, and that was interested in seeing if there was an association between those who took like AP stats and early bird courses and the amount of sleep that they received. Also a very nice, well thought out project. Lots of survey results that she worked with, that this individual worked with.
They're intriguing projects, aren't they?
They're very intriguing, yes. So let's suppose that you decided to submit a project. How would you go about doing that? Well, you would need to go to the ASA website, and here's the website listed here, and you would enter the information, or the student would enter the information here to submit the project. And here we see the deadlines. So for the younger grades, 4 through 6, and then 7 through 9, the deadline is April 1st. But because the AP exam is later in the year, and many teachers requested that we move the deadline to allow people to be able to either finish or do the project after the AP exam, we're moving the deadline for the 10th through 12th graders to May 30th in the coming year. So this is our new deadline for the project competition for 10th through 12th graders. Then we move into the judging, or the project competition. The project competition started by the efforts of Dwayne Cameron in 1987, and Linda Young at the University of Florida has been working with the project competition since 1993. And I just started. I started with the last judging competition last year. The projects are submitted like for the nation. So if you're interested in judging, please let me know. We definitely need judges to help us. And it's done all through email. How does the judging work? Well, we have a teacher and a statistician look at every project. And we feel that this is really, really important because this helps us make sure that the projects are correct statistically and our expectations are age appropriate. So that combined effort is really, really important to the project competition. The way that it works is if we have a large amount of projects, such as for usually the upper age group, we divide the projects into groups of about 6 to 10. And each of those projects are graded on a rubric that contain these 6 items. Each of these areas is worth up to 3 points. Then the top projects move on to a second round. So let's look at that rubric just a little bit more closely. This is also on the ASA website, and this is really helpful to look at and to share with your students so they can see how the project is going to be judged and what are considered good features in a project. So then the top winning projects move on to the second round, and then all the statisticians and teachers look at those and give a lot of thought into which ones get which awards. So here are the awarding levels. So we divide the students up into 3 age levels, so 4 through 6, 7 through 9, and 10 through 12. So the first place winners get $200, a certificate, and a plaque. Second place is awarded $100 and a certificate. Third place, $50 and a certificate. And then honorable mention, a certificate and a ribbon. Also, due to the generous support of the Texas Instrument, first place winners and their advisors will be awarded graphing calculators. Now we get to the frequently asked questions. We often have teachers who say, well, my students are already doing science fair projects. Can we submit those? Can the students submit those as well? And the answer is yes, kinda. With the ASA project competition, we're really looking at the design of the study and the analysis of the study. So that means that a lot of the research background information that's used in a science fair project is not needed as much of for this particular project write-up. We need a little bit of background information to be able to understand the project, but our focus is on the design, analysis, and reflection of the project. So the write-up should be revised before submitting to the ASA project competition. Another common question we get is how much help is too much help? All of us have seen projects where it looked like it was obvious that the parent helped. What we have decided is that it's okay for the students to seek help from parents, teachers, and professional scientists. However, the projects really need to be student-driven. The student really needs to have the question, and the student needs to be the one going through each of the steps. They need to understand completely what was happening in the project. And if they did receive help, then they should acknowledge that in the project, how much help was given and by whom. And then finally, lots of the ideas in this presentation, this webinar, come from the ASA project website. So I encourage you to go there and look at more of the information that's there. Linda Young, Linda Quinn, and John Schulberger have contributed to the text on that website. So are there any questions?
Yeah, I've got one. Is this just one student doing it? They can't work in pairs or anything?
They can definitely work in pairs, and
Okay.
they can work up to groups of 4 for the older age groups.
Okay.
For the 4th through 6th grade, they can actually do it as a whole class.
Okay.
This year, the winners just happen to be single people.
You have previous projects posted on the website, don't you?
At the moment, I don't believe that they are.
No.
Is that right,
Oh,
Rebecca?
actually, the winning projects are currently posted on the website. You just have to go near the top. There's a link that says 2008 Poster and Project Competition Winners, and you can actually download. You can actually read their projects.
I thought so. That would be a good reference to have. So, Megan, it would sound to me like, help me here just a little bit, but since the emphasis is not on, as you said, two-way ANOVA with interactions and so forth, the graphical presentations are a particularly important part of the projects, because that's really where the analysis is going to be communicated to the reader.
That's right.
Would that be correct?
That would be right, particularly for all of the age groups except for maybe the 10th through 12th.
Mm-hmm.
The graphics are the keystone of the project. They're very important.
I think that they are. Any other questions for Megan today?
Would it be possible to get the PowerPoint?
Yes. I can give it to you, or we can, I don't know if there's plans on putting this on the ASA website, but I can definitely send it to you otherwise.
Okay.
Yeah, will it be posted?
We will definitely post the webinar, and actually, Megan, if you send me your PowerPoint presentation, we can post the PowerPoint in addition to the actual recording.
Definitely, I'll send that to you today.
Sounds good.
Well, Megan, thank you very much. We appreciate the time and effort you put into this, and it's been very, very helpful. And we'll see if we can expand the ASA Student Project Competition further around the country. Thank you,
Thank you
Megan.
very much.
Wonderful. Thank you.
Thank you.
Thank you.
Cool. Is Rebecca or Paula, are you still there?
Yes.
I'm here.
I just wanted to make sure that it was appropriate. I'd like to forward this PowerPoint to the math teachers in my program, and I just want to make sure that's cool.
It's cool with me.
Me
That's
too.
fine
And
with
actually, if we put it up on the website, then we can even, you can forward the link that has the webinar presentation and the PowerPoint.
Yeah, that's why I wanted to see if it would be posted, because I thought that'd be better.
Absolutely. Both are needed.
Yeah.
That sounds great.
Excellent.
Excellent presentation.
Yeah, great.
Yeah, absolutely. Glad I made it.
Well, Stacy and David, thank you for joining us today.
Yeah, thank you for doing this. This was wonderful.
Yes, thank you very much. Thanks for coming.
Yeah.
Let's talk to you again.
Signing out. Thanks.
Thanks, Megan. It was wonderful.
Thank you, Rebecca, for all your help. And Rick over there.
Megan, does that sound okay with you? If we put it up on the website, if the teachers share it with each other and things?
Oh no, that's wonderful. That's exactly what we want, is for people to share this information, so we can get more people to participate in the project competition. That's wonderful.
Excellent.
Yeah. Hopefully I can get someone to do it.
That's great.
Yeah. All right. When do you expect that'll be posted? Tomorrow or the next day or so?
Well, we can get the PowerPoint up pretty quickly. We'll have to see about editing, how long it'll take to edit the webinar to kind of cut out the the beginning and the end a little bit. I think we start, it starts recording early just to make sure it's functioning, and then we edit out the kind of the chatting before. But I'll find out. We can at least get the PowerPoint up soon, and then I'll find out about the webinar. Maybe a week or two.
Cool. Actually, I hope, this is Rick. I do the editing. I hope to have it done by the end of the week.
That sounds great.
Okay. Well, I'm going to shut down the webinar now, so everybody have a great evening.
Okay, thank you.
Thank you.
Thanks so much.
Yeah, I'm going to as well. Thanks again.
Thank you.
Thanks.
Bye.
Bye.